Hello my dear students. So today we are going to discuss 29 carefully selected chemistry questions for RE-NEET aspirants. हर एक क्वेश्चन बहुत ज़्यादा इंपॉर्टेंट है to revise your concept and to improve your problem solving skill. हर एक क्वेश्चन को सॉल्व करो. जब भी मैं क्वेश्चन दिखाऊंगा try to solve within 1 minute. As you know, every question per minute you have to solve, right? If you can solve within 30 seconds, that is the best thing. So first you will try, then you will see the solution. Again I am repeating the same statement. हर एक क्वेश्चन बहुत ज्यादा इंपॉर्टेंट है for RE-NEET 2026. So let's start. So this is our first question. Can you solve this question within 30 seconds? Just check. The energy absorbed by each molecule A2 of a substance is 4.4 into 10 to the power minus 19 joule. Bond energy is given 4 into 10 to the power minus 19 joule. So you have to calculate kinetic energy of the molecule per atom. So what will be the answer in this case? Just mark your answer. See, in this case, how to find out kinetic energy? Total energy which is absorbed, which is 4.4 into 10 to the power minus 19. Next, bond is there now. For example, A and A, some bond, it can be 1 bond, 2 bond, 3 bonds, any bonds will be there. So means to break this bond, it needs some energy, right? ये कितना energy है? ये 4 into 10 to the minus 19 joule. So first, whatever energy it absorbs, some portion will be spent to break this bond, and that excess energy will be converted to kinetic energy. Simple calculation. So this is kinetic energy minus 4 into 10 to the power minus 19. So whatever you are getting, and unit will be the joule, this energy will be converted to kinetic energy. So you are getting 0.4 into 10 to the power minus 19 joule. Now just check. This kinetic energy is for 2 atoms because you are getting 2A, right? 2 atoms. They are asking per atom. So per atom means you have to divide by 2. Per atom means just 4.4 divided by 10 to the minus 19, which is 0.2 into 10 to the power minus 19 joule. So now just check the option, which one is your correct answer. So we can write this one as 2 into 10 to the power minus 20 joule, right? So which answer? 2 into 10 to the minus 20. So answer should be A, correct? Answer should be A. Done. So this type of question is very important because this time we are expecting that some numerical based question will be there. So this is one example. Achha, let's go to the next question. This one. Can you solve this question within 1 minute? Statement based question. So Balmer series we have, and lowest energy possible, they are giving 5 by 36 RH, Rydberg constant, centimeter inverse, that is the unit. Statement 2, when the temperature of black body increases, the maxima of the curve, intensity and wavelength shifts to shorter wavelength. So you have to identify correct statement. So how we will answer this question? So you have to verify these two statement, right? So Balmer series, what is its energy formula? They are asking energy, right? So I'm giving simple example. This is very famous equation, you have to remember. E equal to h nu equal to hc by lambda. Now the unit of energy is joule here because hc is involved. Now 1 by lambda, can you replace this 1 by lambda as rz square? Rz square means r is z square into 1 by n1 square minus 1 by n2 square. This is Rydberg equation, right? Now just check. In the final unit we have centimeter inverse. So that's why we have to divide this entire thing with hc, right? So divide this entire thing with hc. So hc will cancel out and we will get this part. Now just put the value. RH, and this is for hydrogen. Hydrogen atom means 1 into, for Balmer series, what is the transition? That levels, energy levels. For lowest energy, so it basically means 3 to 2, right? Lyman means 1, N1 will be 1, Bummer 2, Lyman, Bummer, then Passion, Brackett, Fund, Humphreys. 2, 3, 4, 1, 2, 3, 4, 5, like that. So here 1 by 2 square minus 1 by 3 square. This will be the calculation. Now if you calculate, what you will get? So 2 square means 1 by 4, RH into 1 by 4 minus 1 by 9. So you will get RH into 4 into 36, 9 minus 4 divided by 36. So basically you are getting 5 by 36 RH. Yes. And here the unit will be centimeter inverse, because already we divided that entire equation with HC. So unit will be centimeter inverse. So first statement correct. Now second statement, when the temperature of black body increases, the maxima of the curve shifts to shorter wavelength. Yes. So here actually in black body radiation, lambda max, it is inversely proportional to temperature. Lambda max, it is inversely proportional to temperature. So when any black body absorbs heat, first red type of color you will get, IR region or red region. After that it will go towards yellow region, right? So after that bright white and to the blue range. So basically from longer wavelength it is coming to a shorter wavelength. So that's why if temperature increases, then lambda max will shift to the shorter wavelength. Correct? So both the statements are correct. So option C should be the correct answer in this case. Yes. So see, this question utilizes that Rydberg equation. Just check this one. So transition they're asking, okay, how much energy is involved, and also this question involves black body radiation, so that concept, right? So this is very important question. Acha, next, this question. Can you solve this question? Just if you see some few examples we have, whenever we see alkali metals or alkaline earth metal. Alkali metal means lithium, sodium, potassium, rubidium, cesium. Alkaline earth metal means beryllium, magnesium, calcium, strontium, radium, right? So basically this series, group 1, group 2, mostly they will form basic oxide. Basic oxide. If I give example, Na2O, sodium oxide, basic oxide, right? If I consider non-metal oxide means, let's consider Cl2O. Cl2O, both are non-metal, and see, chlorine is towards right side of periodic table, right? So when something coming from the right side, that should give acidic oxide. That must be acidic oxide. Okay. So in the periodic table, if elements or metals are involved, which are coming from S block, mostly basic. If you are getting from the right side, if you are getting elements from the right side where highly electronegative species involved, so in that case acidic oxide. And if you see the middle edge, so this portion here, you can get neutral oxide or amphoteric oxide. So this is the idea. Extreme right means acidic, extreme left means basic, and in between neutral and amphoteric. These two things will be there. Now just check barium oxide. Yes, this will be basic oxide. Correct? Now Cl2O3, again chlorine and oxygen more electronegative, which are coming from the right side, so acidic oxide. Now just if you see these two things, if you merge, so B should be with 1, B with 1. Anything else is there? Nothing else is there. So by default your answer is here, right? So just match other options. Cl2O3, so D should be with 3. D should be with 3, correct. Next, aluminium and CO. See, carbon monoxide, CO, NO, N2O, these are all neutral oxide. These are all neutral oxide. These are all neutral oxide. So A should be with 2. A should be with 2, correct. And Al2O3, aluminium oxide, zinc oxide, tin oxide, these are all amphoteric oxide. These are all amphoteric oxide. So C is with 4. So these are all, information based question. Only if you remember these two things, extreme left means extreme left means basic oxide, extreme right side means acidic oxide. I'll give you another example, like for example NaOH. This is base, right? Already we know NaOH, KOH, right? These are all base. Acid, HCl, correct? HCl, this is acid, right? So just remember this thing. Then H3PO4, acid, right? H2SO4, right? These are all acid. So acids are coming from right side, bases are coming from left side, and in between we have neutral oxide, neutral and amphoteric oxide. So some examples you have to remember to answer this type of question. This is basically, you can say, information based question. Although we can solve ये दो एग्जाम्पल लेके we can answer. अगर ये दो एग्जाम्पल तुमको आता है कि लेफ्ट साइड से बेसिक, राइट साइड से एसिडिक ऑक्साइड आता है, तो you can answer this type of question. But if they frame tricky question, then you have to know that detailed information, which one is called acidic, which one is called basic, then amphoteric and neutral. Mostly neutral and amphoteric, these two things you might be confused. So for that purpose I have, so here answer is C. Yes, I have this table. So examples are very important. Examples are very important. So if you consider first one, basic oxides, just check sodium oxide. So here we have sodium oxide, then calcium oxide, magnesium oxide, copper oxide, Fe2O3. So these examples, although group 1, group 2 involved, and also some transition metals also involved, right? So these are examples of basic oxides. Now acidic oxide, if you see, CO2 is special case. CO2 in water, CO2 in water acts as acidic oxide. But if you consider normal case, it will act as neutral oxide. Then SO2, SO3, P2O5, N2O5, Cl2O7. So these are all acidic oxide. Now these two are very important because you might be confused with this. Aluminium oxide, zinc oxide, beryllium oxide, tin oxide and lead oxide. So beryllium, it is involved in group 2, still it is giving amphoteric oxide. The reason is beryllium mostly form covalent compound. Although it is a metal, but it forms covalent compound, right? So that is the reason. So here these 5 examples, aluminium oxide, zinc oxide, beryllium oxide, tin oxide, lead oxide, these are all the examples of amphoteric oxide. अगर ये न्यूट्रल ऑक्साइड को देखो तो यहाँ पे कार्बन मोनोऑक्साइड CO, NO, N2O, H2O and CO2 special case. Normal condition means neutral oxide. If you put CO2 in water, then acidic oxide. So these examples you must remember because mostly based on these oxides they frame questions based on these examples actually. Okay, so you must remember these examples. Acha, this is done. And definition already I think you know. Basic oxide means if it reacts with water it will produce base like NOH, KOH, or it will react with acid. Both means basic oxide. Acidic oxide means it will react with base or it will react with water and form acid. Both are correct, right? Both are correct. Amphoteric means it can react with both acid and base, and neutral oxide means, as the name suggests, it does not react with anything else. It does not react with acid, also it does not react with base. So this is the idea. This is very important section. Okay, chalo, next one. This question, can you solve this question? So based on ionization enthalpy, see, although ionization enthalpy, this enthalpy and energy, these two are different meaning, but mostly whenever we have question, almost we will treat them similarly. Okay, ionization enthalpy or ionization energy, we will treat them similarly. If you want to get any trend, okay, is there any trend, you are trying to find out that trend, so just consider both, almost same thing, then you will get the same answer. Acha, so we have two elements, X and Y. Now just check 419, this is first ionization enthalpy, IE1. Next, second is 3069. So 419 and IE2, this is giving 3069. For Y, it is 590 and second one is 1145. 1145. So first you have to remember, ionization energy means, suppose we have one atom. Now we are applying some energy, and which we are calling ionization energy. Means we are supplying some amount of energy, and then what you will observe, this atom will lose electron and you will get one cation, correct? Ionization means you are converting atom into a cation by losing electron, and this whole process will be in gaseous state. Always remember, this whole process will be in gaseous phase only. So this is the ionization. Now if you want to remove one more electron from this, so IE2, this is IE1, this is IE2, so you will get A2 plus, correct? Now always remember, from neutral you are getting plus. Let's assume you supplied 100 units of energy. Now here plus charge is present. That means nucleus is strongly holding all the electrons available in it. Nucleus is strongly holding all the electrons. Positive charge means more positive charge than electrons. So that's why you have to supply lot more energy to remove another electron from this cation. So here if it is 100, let's consider here it is 120. Means point is, it must be, it must be greater than 100. It must be greater than 100. That is the idea. To remove a electron from a from an atom, this process is easier than removing an electron from a cation. Okay, so this is the idea. So that's why if you keep removing electron, normally ionization energy will increase step by step. Now here if you see this question, normal trend is like जितना इलेक्ट्रॉन निकालोगे उतना आयनाइजेशन एनर्जी बढ़ जाएगा, लेकिन कितना बढ़ेगा, दैट रेट यू हैव टू चेक, कितना एनर्जी ज्यादा लग रहा है. जस्ट चेक हियर फॉर फर्स्ट एग्जांपल, 419 से सीधा 3069, सो ह्यूज गैप इज देयर, राइट? सो दैट्स मीन this X, it must have only one valence electron. Only one valence electron means only one electron is available in the outermost shell. So that's why for first case it is easier to remove. But if you consider all other electrons, they are already fulfilled configuration, they are inside. So that's why second electron you cannot remove easily. You have to supply lot of energy. Example, sodium. If you consider sodium, so sodium, what is the configuration? Sodium, if you consider sodium, it is 1s2, 2s2, 2p6, 3s1. Now just check, to remove this 3s1, yes, it is easy. Okay, you can easily remove that. Now up to 2p6, already shells are fulfilled, right? Shells are fulfilled. So it is very difficult to remove electron from this. So that's why, see the changes, huge energy jump is there, means lot more energy is required to remove this second electron. So from this we can easily understand, if one electron is available in the outermost shell, it must be group 1 metal. It must be group 1 metal. So X must be group 1 metal. Second example, you just check, 590 say 1145. Yes, it is increasing. As we know, if you keep removing electrons, normally ionization energy will increase step by step. But this increment is not that much compared with this. It is not that much. So that's mean here at least 2 electrons are available. Since we don't have ionization energy 3-4 data, only we can say at least 2 electrons are available in the outermost shell. So that's mean it can be alkaline earth metal. So it can be alkaline earth metal, which is group 2. And if you see the option, only alkali metal and alkaline earth metals, these two terms are there. So by default your answer will be X is alkali metal, correct, Y is alkaline earth metal. So option A. So this is very, very interesting example or question. Based on that, they can frame lot of question. By compare, you have to compare ionization energy values or ionization enthalpies values, and based on that you have to say how many valence electrons are present in that particular element. So based on ionization energy data, you can actually predict how many electrons are available in the valence shell. So this type of question is very famous. Okay, so this is done for this question. Only you have to compare this ionization energy 1 and 2, that's all. Okay, so here answer is A. Next, this question. Can you solve this question? Non-zero dipole moment. Non-zero dipole moment. So first you have to know the structure of CCl4 and all of this. So CCl4, it is actually perfect tetrahedral, right? This is perfect tetrahedral. And whenever we have perfect tetrahedral, it is not like with CCl4, it can be CH4, right? CI4, anything. Perfect tetrahedral. So that's mean this one and that resultant of this, they will cancel each other. You will get zero dipole moment. So in this case, zero, right? Now CO2, if you consider CO2 is linear, right? So that's mean right side and left side, they will cancel each other. Again, in this case, you will get zero. If you consider BF3, so BF3 is, what is the geometry in this case? Trigonal planar. So in this case, if you consider this one like this, and if you consider this two, and net dipole moment is like this, then they will cancel each other. Perfect trigonal planar means zero. Here also zero. Only HI, if you consider HI, only one single bond is there, and iodine is more electronegative, that's a delta minus, and hydrogen is delta plus. Now just check, charge difference is there, and also gap is there, so you will get dipole. So this is dipole, right? Delta plus, delta minus, so dipole. So yes, in this case you will get non-zero dipole moment. So dipole moment is also one of the important topics. So based on that also you can expect question. Only you have to, you have to know the structure of that particular compound, then only you can answer, right? So this is also very important question. Acha, this is option B. Next, this question. Can you answer this question? You have to match with the list 1 and list 2. Now just check. Here it is not mentioned whether you are comparing shape or geometry. It is not mentioned. So normally see, shape and geometry, these two are different things. Do not be confused. In geometry, only steric number we will consider, steric number we will consider, which is equal to number of lone pairs plus number of bond pairs. But in case of shape, only you will consider bond pair. In this case, only bond pair you have to consider. This is very, very important idea. Sometimes in some question they are asking shape, but you are answering with respect to geometry, means wrong. So whether they are asking shape or geometry, first check that. Here nothing is mentioned, so you can consider both. Based on that you have to answer. Now just check PCl5, how you will find out its geometry. So simple, I'm giving trick. Phosphorus, how many valence electrons it is having? 5. So PCl5, I'm trying to get 5. Phosphorus is the central atom, so it is having 5 valence electrons. Correct? Now out of these 5 valence electrons, now just check how many chlorine we have. 5 chlorine. And we know each chlorine can form only one bond, right? Each chlorine, one bond. Why? Because chlorine belongs to 7th group. So it will form only one bond, then it will become octet, right? So always fluorine, chlorine, bromine, iodine, normally they will form single bond. I'm not considering that exceptional one, means where it is forming 2 bonds, 3 bonds. Normally with phosphorus, okay, normally it is forming one bond. So total 5 chlorine. So that's why all 5 will be used to form this 5 bonds. So number of bond pairs will be 5 bond pairs. There is no lone pair, so 5 bond pairs we have. So steric number is 5. So in that case, what will be its geometry? Like this. At the center we have phosphorus and all chlorine will be like this. Correct? So it means trigonal bipyramid. Trigonal bipyramid. So here we have this geometry. This is trigonal. Okay, this is trigonal, and on the top and bottom there we have two chlorine. So trigonal bipyramid. So see this one, we have this A with 4, A with 4, A with 4. So other two options by default, they are not the correct answer. Next, SF6. So SF6, central atom is sulfur. Sulfur, oxygen, sulfur, they are having how many valence electrons? 6. 1, 2, 3, 4, 5, 6. And 6 fluorine we have. Each fluorine can form only one bond. So total you have 6 bond pairs. So steric number is 6. So what geometry you will get? You will get octahedral, correct? So at center we have sulfur, and all 6 position we have fluorine, correct? All 6 position fluorine. So this is the geometry of sulfur. So it is octahedral. So B with 3, B with 3, B with 3. Okay. Next, BRFI. BRFI. So bromine. Bromine is having how many valence electrons? BRFI. Bromine is having 7 valence electrons, right? 1, 2, 3, 4, 5, 6, 7. Out of 7, 5 electrons are used to form 5 bonds with fluorine. So 5 bond pair, and you are getting 1 lone pair, correct? So total steric number 1 plus 5, or that means 6. So 6 means geometry will be square planar. Means square planar, and two things we have means octahedral. Geometry will be octahedral, square planar, and 2 up and down. Two locations are available. So total geometry will be octahedral. But since 1 lone pair we have, so let's consider this is our lone pair. So it looks like square pyramidal, right? Square. So square planar we have, and above that 1 locants or fluorine we have. So total that whole geometry is called square pyramidal. So BRFI square pyramidal. C with 1, C with 1. So by default we got answer A. Just verify with the other option. BF3. How to find out its geometry? BF3. BF3, what will be its geometry? Boron. How many valence electrons? 3. 1, 2, 3. And how many fluorine? All 3. So 3 bond pair. And there is no lone pair. So steric number 3 only. If we have steric number 3, so it will be like this. Trigonal planar. Trigonal planar. At the center we have boron, and then 3 fluorine. Trigonal planar. D with 2. Okay, so this example, this question, actually it is, if you study this question, so you are revising entire shape, geometry, all those things, right? This is very important question. Okay, so we can expect, they will give some compound. You have to identify its shape or geometry. Okay, so, and how many lone pairs, how many bond pairs, what is the steric number, they can ask. So this is very important question. Answer is A. Next, this one. Pb3O4 reacts with HNO3 and forms PbO2. Statement based question. Lead is stable in +4 oxidation state. What will be the correct answer? So first one, Pb3O4. Pb3O4. Actually, this Pb3O4, we don't have only one type of lead. We have 2 different types of lead. If we split this molecule, actually we will get PbO. 2 molecules of PbO dot 1 molecule of PbO2. So total you are getting Pb3O4. So in Pb3O4 we have 2 lead. In one lead we have oxidation number 2. In other case we have oxidation number 4. Remember, this is very important thing. 2 different oxidation states we have. Now if this Pb3O4 reacts with HNO3, HNO3 is strongly oxidizing agent. So basically in this case what will happen, this lead oxide will be converted to lead nitrate. PbNO3 whole 2. And since lead is already, this lead is already in +4 state, it will be separated as PbO2. And PbO2 you will get one precipitate. So basically Pb3O4 reacts with HNO3 and forms PbO2. Yes, it is correct statement. Next one, they are saying lead is stable in +4 oxidation state. See, if you see that series nitrogen, lead, if you go top to down, then we will see inert pair effect. Inert pair effect. Due to inert pair effect, especially 6s electrons, 6s electrons will be much more closer to the nucleus. So these electrons will no longer use for bonding. ये nucleus के पास में चला जाएगा because of inert pair effect. Because you know that F block comes before this, na? Because of that screening effect, poor screening effect, this 6s electrons will be closer to nucleus, so they will not be used for bonding. So that's why only 2 other electrons which are available in 6p, so those 2 electrons will be used for bonding. So that's why top to down, instead of +4, initially +4 is there, +4 oxidation state means carbon, silicon, germanium, tin, lead. This is our series group, carbon, silicon, germanium, tin, lead. So first for carbon it is +4, no problem. Silicon also +4, no problem. But if you go down, especially in case of lead, only +2 will be stable because it cannot release 6s electron. Only 2p electrons will be, that 6p electrons will be released for bonding or some other chemical reactions. These 6s electrons will not be used. Okay, so only +2 you can get. +2 will be the stable one. See, if you consider, then it is whether it is possible or not that +4 oxidation state. Yes, it is possible. +4 is possible, but that is not stable. If you compare stability of Pb2 plus and Pb4 plus, so I'll say Pb2 plus is more stable than Pb4 plus because of this inert pair effect. So that's why first statement is correct, but second statement is wrong. Okay, so answer C. 1 is true, B is false. And based on this reaction, here we have this reaction. You can just write down this reaction. You can write down this reaction. Pb3O4 plus 4HNO3, PbNO3 whole 2 plus PbO2, and because of that we will get that precipitate. Some precipitate we will observe. This is the idea. So this is also very good question. Acha. Now let's go to the next one. This one. Can you calculate this? The right option for the mass CO2 produced by heating 20 gram of 20% pure. This is very important question. By heating 20 gram of 20% pure limestone. So you have to find out the mass of CO2. How we will find out? See, especially NEET exam, sometimes they give chemical reaction, but sometimes they may not. So that's why remember CaCO3 means CaO plus CO2. This is the reaction. Achha, if you check this reaction, so here molecular weight of calcium carbonate is 100, calcium 40, carbon 12, oxygen 16, and carbon dioxide molecular weight 44, correct? Now just check, here pure limestone means CaCO3, which is 20% pure. So that's mean 20 gram, this is impure CaCO3. So from that you will get pure CaCO3. How we will calculate how much pure calcium carbonate you have based on this information? So what you will do, 20 into 20 by 100, correct? So that's mean out of 20 only 4 gram is your pure calcium carbonate, correct? Out of this 20 gram only 4 gram pure calcium carbonate you have. Now just calculate from, if you have 100 gram calcium carbonate, you are getting 44 gram CO2. So we have 4 gram of CaCO3. What will be the quantity of CaCO2, calcium carbonate, carbon dioxide? What will be the quantity? Just cross multiplication. So 4 into 44 divided by 100. What you will get? 176 by 100 means 1.76 gram. 1.76 gram. Option B. So this type of question is very important. Pure, from pure to impure, from impure to pure, this type of conversion. Since from impure to pure, I'm converting here, so that's a 20 by 100. If I want to convert pure to impure, then 100 by 20, right? So this type of conversion is very important. This is very, very standard question in stoichiometry. Okay. Chalo, next question. So here answer is B. Okay. Can you solve this question? Just try to solve. A compound X contains 32% of A, 20% of B, and remaining percentage of C. So these are all, whenever we have this type of percentage, always consider mass ratio. Then the empirical formula they are asking. This is also very, very standard question. So we have A, B, AB and C. A quantity is 32%. Next B is 20%. Then what will be the percentage of C? So 32 plus 42, 52 means 48. This is mass percentage, okay? Mass percentage. Now we have to find out formula. So whenever from mass percentage we have to calculate empirical formula or molecular formula, always we have to convert that into mole ratio. So what will be the mole ratio? Mole ratio. Just divide this entire thing with their atomic weight. So A, atomic weight of A is 64. So 32 divided by 64. Then for B it is 40. 20 by 40. Then C means 48 by 32. This is the ratio, right? Next, just you have to simplify. So here 2 we are getting, here 2 we are getting, and here 3 by 2. 3 by 2, correct? So now if you multiply this entire thing with 2, then we will get 1:1:3. So that's mean A will be 1, B will be 1, and C will be 3. So in which case we are getting? Option B. So in this case, they are asking only empirical formula. If they are giving molecular weight using vapor density, I think you already know, vapor density means molecular weight divided by 2. 2 is coming from hydrogen. So sometimes they can ask molecular weight. First you have to calculate, you have to get this empirical formula, then from this you will get empirical weight, and using this equation, sometimes vapor density they will give, you have to get molecular weight, or sometimes they will directly give molecular weight. So using that you will calculate n factor and you will find out that final molecular formula. So this is very, very standard question. From mass percentage you are getting empirical formula. Okay. Chalo, next one. So your answer is B. Next, this question. Can you solve this question? At a given temperature and pressure, the equilibrium constant values of the equilibria, so these are given. So correct relation, Q1, Q2 relation they are asking. How we will get that? These two equations are given. So if you see from outside, you may think, अरे बाप रे ये बहुत ज़्यादा difficult question होगा क्योंकि इतना chemical equations, equilibrium, this type of things are there. But it is very easy. Very easy. Just check. Here only one one molecule is there. In this case, 2 molecule we have. So let's convert it into 1 molecule. So this equation can we write in this way? If I do opposite 2A3B, from that 3A2 plus B2. Since we are reversing this equation, instead of K1, we will write 1 by K1. When we reverse a reaction, since we reverse this equation, K will also be reversed, means 1 by K1. This thing will be there. Now, अभी क्या करना है, ये पूरा इक्वेशन को हाफ से मल्टीप्लाई करना है. अगर पूरा हाफ से मल्टीप्लाई कर दो, इधर पावर में हाफ आ जाएगा. सो कैसे होगा ये? सो A3B, from that we are getting 3 by 2A2 plus half B2, and this one will be 1 by K1 to the power half. Correct? Now just check this given equation and this equation, both are exactly same, right? So that's mean K2 and this thing will be equal, na? K2 will be equal to 1 by K1 to the power half. That's mean K2 equal to 1 by root over of K1. So option D. So very easy question. So only what you need to do, just sometimes just get the same A3B in one side, means product or reactant must be in the same side in both the equation. That is the starting point, and then try to make just similar pattern from one of the given equation. Means just do like this, reactant को एक साइड में लाना है, प्रोडक्ट को एक साइड में लाना है, उसके बाद कंपेयर करना है नंबर ऑफ मॉलिक्यूल्स को. उसके लिए you can divide, you can multiply, whatever you can do, and always remember whatever you are doing there, that equilibrium constant, there also you have to do that thing. Means if you multiply, then you have to give power. That fraction will be in the power of this equilibrium constant. If you are reversing equation, then 1 by equilibrium constant will be there, right? So this is the basic rules in equilibrium. So this question is coming from chemical equilibrium. Very, very important question. They can give lot of question based on just this idea. Okay. So here answer is D. Chalo, next question. This one. This is also calculation based question. How we will find out? These are all equilibrium concentration. These are all equilibrium concentration, and 0.1 mole per liter means molar NO is given. Then we have to find out degree of dissociation. Degree of dissociation we have to find out. How we will calculate this one? Acha, from this equation, can we calculate? Since see the concentration term, all are in molarity. Molarity means which equilibrium constant will be there? Kc. So Kc equal to, how we will write Kc for this equation? N2 concentration into O2 concentration divided by NO concentration square, right? Because of this 2, we will put square. Then what will be the value? N2. N2 value 3 into 10 to the power minus 3 multiplied by O2. O2 is 4.2 into 10 to the power minus 3 divided by NO. NO is 2.8. 2.8 into 10 to the power minus 3 and its square. Correct? Now from this 10 to the power 3, 10 to the power 3 and 10 to the power 3, they will cancel each other because here we have square. So from this 3 into 4.2 by 2.8 square. So Kc is coming 3 into 4.2 divided by 2.8 into 2.8. Now 4.2 and 28. So can we do? So 3 square divided by 5.6. Can we do this one? 3 square by 5.6. So Kc is coming 3 square by 5.6. Correct? Kc is coming 3 square divided by 5.6. Now again just we have to write the same equation, 2NO, from that N2 plus O2. This is our equation. We have to find out degree of dissociation. Now just one concept we have. Let's consider at initial stage concentration of NO is C, and since reaction didn't start, other two concentration is 0, means both other two cases it will be 0. Next, at equilibrium C into 1 minus alpha is degree of dissociation, means why I am writing that one, so C minus C alpha. So C alpha will be degraded, right? C minus C alpha means C into 1 minus alpha. So here it will be C alpha by 2 and here also C alpha by 2. How I am writing C alpha by 2? Just check. From 2 molecule of NO, I am getting 1 molecule of N2. Then if this is the molecule of NO, this is the remaining. How much is converting? Only C alpha is converting, right? If 2 molecules of NO, it is giving 1, and then C alpha molecule of NO is converting to C alpha by 2 molecules of N2. Same logic. Again I am repeating, this is very important, and here most of the students are stuck. 2 molecules of NO, they are converted into 1 N2 molecule and 1 O2 molecule. And now at equilibrium, here what we are considering, only C alpha molecules, they are converting into N2 and O2. So from C alpha, how many molecules of N2 will be there? C alpha by 2. For O2 also C alpha by 2. Okay. Yes, this is our equation. So can we write equilibrium constant for this also? Yes, we can write. So Kc will be equal to, so this one C alpha by 2 means N2 concentration into, again that one C alpha by 2 O2 concentration divided by NO concentration is C into 1 minus alpha, and since square we have, so we have to put square, correct, just like before we did. So from this what we are getting, so C will be cancelled with each other, so alpha square by 4 into 1 minus alpha square. So this thing we are getting. Now this alpha means this Kc value and what Kc value we got there, so this must be equal, right? Alpha square by 4 into 1 minus alpha square, correct? We are equalizing these two things. Now from this equation, can we find out alpha? Yes, we can find out. So we can write alpha by 2 into 1 minus alpha will be equal to 3 by, now root 5.6, what value you will get? Root 5.6, what value you will get? Say, I know it will, it seems very difficult thing, right? But in NEET exam, mostly if you do approximation method, then you will get the answer. Why I am saying, if you do root 4, you will get 2. Root 9 means you will get 3. Now this 5.6, it is in between 4 and 9, correct? So I can expect this will be right 2.2 or something. Again try to understand. Root 4 means 2. Root 9 means 3. We have to calculate 5.6. So that means this 5.6, root 5.6, its value must be in between 2 and 3. Since this value is closer to 4, I am just writing 2.2, just any random closer to 2, so 2.2. Now let's put the value. So here I am writing 2.2. So that means 2.2 alpha. From this we can write 2.2 alpha equal to 6 minus 6 alpha, correct? So that means if it comes this side, what we will get? 8.2 alpha equal to 6. So alpha will be equal to 6 by 8.2, correct? Now if you consider, if you just ignore this 0.2, 6 by 8, only this thing you need to calculate. What you will get? Put 0 point means 60 you are getting, and 7 into 8 means 7. So 0.7 something you will get, correct? 0.7 something you will get. Check the option. Check the option. 0.7 something. Do you have anyone? Yes, option D. See, no need to calculate that exact thing. Only using approximate method you can get the answer, because options are there. And yes, if there is very similar options, then you have to do exact calculation. Otherwise, by doing rough calculation or approximate calculation, you can find the answer. Okay, so just check this one. What I have done, that is totally rough or approximate method. Based on that also, we are getting answer. Okay, so that's mean here answer is D. Answer is D. Chalo, next question. This one. KSP value of Ag2CrO4, then AgCl, AgBr, AgI, these are all given. Then which one of the following salts will precipitate last if AgNO3 solution is added to the solution containing equal moles of this. So basically we have one solution here, Cl minus, Br minus, I minus, CrO4 2 minus, all are having same mole number. So now precipitation, it will depend. Precipitation will depend on Ag plus ion concentration. Ag plus ion concentration. Now, this is the, one concept is here. Pay attention. If Ag plus concentration requirement is low, then precipitation will be very fast. If concentration requirement, Ag plus concentration requirement, if Ag plus concentration requirement is less, then precipitation will be more. This is the connection. Ag plus concentration requirement, if it is less, means for precipitation, if it needs little amount of Ag plus concentration, that precipitation will be happening. Now just check. Now just how to find the answer in this case. Since they are saying all these Cl minus, Br minus, I minus, CrO4 2 minus, their concentrations are equal, their mole number is equal, I am considering it is 1. Correct? All of them are having unit mole number, 1 mole number. Now just calculate for Ag2CrO4. Ag2CrO4, what is the formula? KSP value is equal to Ag plus square into Ag plus concentration square into CrO4 2 minus, correct? This is the formula, and KSP value is given 1.1 into 10 to the power minus 12, which is equal to, and we are considering this chromate is 1, because for everyone we will consider that anion part concentration is having 1 unit. So Ag plus to the power square. So that's mean Ag plus its concentration requirement will be almost, see the power 10 to the minus 12. So here it will be 10 to the minus 6, correct? So for chromate part, for silver chromate precipitation, it needs silver ion concentration in the order of 10 to the minus 6, means 10 to the minus 6 level. That range you have to give. Now for AgBr, now if you consider AgBr, for AgBr, what is the KSP value? For AgBr, it is 10 to the minus 10. So Ag plus and Br minus, what is the order? 10 to the power minus 10. So here Br minus is unit concentration. So Ag plus concentration requirement will be 10 to the minus 10 order, correct? Next AgI, Ag plus into I minus, what is the order? 10 to the minus 13. So 10 to the minus 10, that is for AgBr. Okay, then AgI, sorry, that is for AgCl. 10 to the minus L, this is for AgCl. This is for AgCl. Ten to the minus 10, that is for AgCl, Cl minus, same calculation. So for AgCl, we need 10 to the minus 10 order. Then for AgBr, it is in the order of 10 to the minus 13. 10 to the minus 13. So that's mean here also Ag plus concentration requirement will be in the order of 10 to the minus 13. And last one, AgI, Ag plus and I minus. So here requirement is 10 to the minus 17. So that's mean Ag plus concentration requirement will be in the order of 10 to the minus 17 only. Now just verify with all these answer. Just compare all these answer. First case, 10 to the power minus 6. This is for Ag2CrO4. 10 to the power minus 6 is higher value, right? 10 to the minus 6. Next, 10 to the power minus 10. 10 to the minus 10. Next, 10 to the minus 13. Next, 10 to the power minus 17. So for chromate, this is CrO4, CrO4 2 minus. You need huge concentration of Ag plus because 10 minus 6, it is the higher value, right? Highest value if you compare all of these. So that's why, since in case of Ag2CrO4, Ag plus concentration requirement is maximum in this case, that's why here precipitation will be less. So here concentration requirement is maximum, that's why precipitation will be at the end, at the last. Answer is B. So this is very, conceptual question. Again, I am repeating the same philosophy here. If concentration requirement is less, precipitation will be fast at first. If concentration requirement is very high, then precipitation will be at the end, at the last. So this is the idea, and based on that we have this full question, this entire question. Okay, this is also very, very important question. Next, here answer is B. Okay, chalo. Next, this question. Which will make the basic buffer? How we will solve this question? See, basic buffer means always you have to remember, whenever we say basic buffer, so some base will be there. Basic buffer. So buffer is anything which will try to resist the change in pH if we add extra few drops of acid or base. Okay, so basic buffer means it must have one base and weak base plus its salt. Let's take one example, NH4OH, and if we have NH4Cl in the medium, so salt, see, salt of that, base and its corresponding salt, and that salt must be produced with the help of strong acid. That is the idea. So base and its corresponding salt of strong acid. So this is the idea. This thing must be there. Now, if you check the option, first case NaOH and CH3COOH, both are there. Now this is strong base, and this is weak acid. So by default it is not basic buffer, right? It is not basic buffer, because for basic buffer weak base must be there. Where is weak base? This is strong base. Next option, weak acid, strong base. Again, this is not the correct answer. Next, if you check here, strong acid we have and weak base is there. Yes, we have little hope. And if you see the last one, HCl, NaOH, nothing is weak, both are strong. So this is not also the correct answer. So option C will be the correct answer. But as I mentioned, ammonium hydroxide, NH4OH, and its salt must be there. But here HCl is there. HCl is not salt, it is acid. Then how it is correlating? Just check. NH4OH, if it reacts with HCl, then it will produce NH4Cl plus H2O. Now just check, see the mole number. In case of HCl, what is your mole number? So 100 into 0.1. 100 into 0.1 means 10 mole, right? 10 millimoles. 10 millimole you are getting. So from this we will get 10 millimole. 10 millimole acid is given. Now base 200 into 0.1 means 20. So 20 millimole base is given. Now when acid and base they react, they will neutralize each other. So 20 millimole, here HCl is the limiting agent. HCl is the limiting agent because we have less mole number here. So 10 millimole will take 10 millimole of NH4OH, right? And it will form 10 millimole of base. So that's mean after reaction AR, what is the amount or mole number of NH4OH? 10 millimole. What is the concentration of HCl? 0, because all HCl converted to NH4Cl, and NH4Cl 10 millimole. So that's why when you react, when you if you do reaction with this concentration of HCl and NH4OH, at the end of reaction you have NH4OH 10 millimole and you have NH4Cl 10 millimole, as I mentioned here. So that's mean it will give basic buffer, right? Buffer related question again we are expecting. So this is very important topic, how to calculate pH for buffer solution, acidic buffer, basic buffer, right? And only one example I have given. So what are the other examples? So based on that we have this topic. So here answer is C. Okay, so this is based on that concept. So this is very important slide. So this is pH calculation, pK plus log concentration of salt. This is salt, concentration of salt by concentration of acid. An example, just check, this is one example. Acetic acid plus sodium acetate, then H2CO3 carbonic acid and its corresponding salt, then H3PO4 phosphoric acid and its corresponding salt. So these are example of acidic buffer. Now basic buffer, here you can see NH4OH, NH4Cl, famous one. Next, dimethylamine and dimethyl ammonium chloride. Last one is Na2CO3 and NHCO3. So these are the examples of buffers. And for basic buffer, pH, first we have to calculate pH, which is pKb plus log of concentration of salt by concentration of base, and from that we can get pH, which is 14 minus pH. Again, this slide or this question, it will if you solve this question and if you study this one, that entire buffer thing you can revise. Okay, chalo. Now next question, this one. Can you solve this question? Can you solve this question? Just check. So basically for this combustion reaction, this is our combustion reaction. From glucose we are getting CO2 plus H2O. For that we have to calculate free energy change. And what free energy? Standard free energy change you have to calculate. And all standard free energy of formation of glucose, CO2, H2O all are given. So how to find out the answer? First see the equation. C6H12O6. From that you are getting 6 CO2 plus 6 H2. This is the idea, means this is the reaction. Now just check, is it balanced? No, because we have to put oxygen. So how many oxygen we have to put here? Total there 12 and 6, 18 we have, and here 6. So that's why 6 O2 we have to put. So oxygen, now oxygen is balanced. Now already we know if something is present in its elemental stage like oxygen, in that case free energy of formation, standard free energy of formation will be 0. So for oxygen we will consider 0. Formation of Gibbs free energy of O2 formation, so that will be considered as 0. Now how to find out that for this is a combustion reaction, because in combustion reaction always we know that substance it should react with oxygen, it will produce CO2 or H2O or both, plus lot of energy will be generated. That is the definition of combustion reaction. So here delta G standard, it means delta G product minus delta G reactant. This is the normal formula, right? The change in Gibbs free energy for this reaction is product minus reactants. Now in case of product, we have two different product, CO2. So for CO2, what is the value? Minus 394. Minus 394.5. Since 6 molecules we have, multiplied by 6, I am giving third bracket, plus, let's give first bracket here because another thing we will have. This is first bracket. Next, another product H2O. For H2O, what is the value here? Minus 237. Minus 237.2 into 6. Correct? Into 6. And this is entire product. Minus reactant. So reactant is, for oxygen it is 0 because it is in standard state. Now for glucose, what is that? For glucose we have 910.5. So minus into minus, it will become plus 910.5. So this is the calculation. Now if you do calculation, again no need to calculate exact thing, approximation we have to consider. So if we consider approximate method, just see how easily we can get the answer. This is 394, it is closer to 400. So if we consider this entire thing as 400, so 4 into 6 means minus 2400, correct? Done. Next, plus minus minus means here 237. Let's consider 200. Let's consider 200. 200 into 6 means 1200. Done. Next, 910. Let's consider 900. 900. If you do this thing, then what you will get? So 2600, then 3600 minus 900. So almost 2700 you will get, right? Almost minus 2700 you will get kilojoule. Now check the answer, in which case it will be closer. In which case it will be closer. 2700 के आसपास होना चाहिए. Only 287, only 28, only 57. Here 2879. Yes. Option C is the correct answer. In NEET, we have maximum 1 minute per question. So if you want to do exact calculation, time will not be enough. Use approximation method. Okay, so in this case, answer is option C. Achha, now this question, how we will solve this question? So which of the following PV curve represents maximum work done? So here one idea we have how to find out work done. So which is equal to area under the curve. So if you know this thing, you can find the answer. In this case, just check, this is the entire portion, area under the curve. Here, yes, this one is the area under the curve. In this case, this one, and here nothing. So in which case area under the curve is maximum? Option A. So here, in case of A only, we will have maximum work done, right? So if you look at only diagram, then you will be confused, you might think something else, but this is our, mantra. Work done means area under the curve. You will get the answer. Okay, next, this one. The correct increasing order of the stability of +1 oxidation state of this. So aluminium, gallium, indium, thallium, right? Indium and thallium. So these are the element of boron family, group 13. So group 13 means normally they show 3 plus or plus 3 oxidation state, 3 plus charge or plus 3 oxidation state. But if you go top to down, as I said, inert pair effect will be there, right? Decontraction, then lanthanide contraction, means inert pair effect, so that will be coming. So that if you consider this one, this 6s and 6p, 6s2, these electrons will be closer to nucleus, so they cannot participate in chemical reaction. So only last electron will be participating. So that's mean if you go top to down, plus 1 oxidation state will be increasing. That stability of plus 1 oxidation state will be increasing. Okay, so now just check the order. Maximum is thallium, aluminum, gallium, indium, thallium, option B. If you go top to down, lower oxidation state will be stabilized, right, because of that inert pair effect. So option B is the correct answer in this case. Again, this is this is relevant in, it can be considered in P block element or classification of elements, means that Mendel periodic table, that chapter. So this is very important concept. Now this one, how we will find out? They are asking not correct about diboron. This is famous molecule in inorganic chemistry. So you must know the structure of diboron. B2H6, right? B2H6. So here one hydrogen like this, another boron we have. Now if you consider them as individual molecule, then you will do mistake, because diboron means these two hydrogens, they will form hydrogen bond like this, and that banana bond is also there. So let's draw in this way, just drawing like this. So this entire thing, it is called bridge bond. That is also called bridge bond. So how many bridge bond we have? 2. And if you check this boron hydrogen, this bond, it does not have any electron, but this BH, yellow one, here we have 2 electrons. So that's why here we have 3 centered 2 electron bond. How many? Total 2. 3 centered 2 electron bond we have. This BH, total 4 terminal hydrogens we have. Total 4 terminal BH bonds we have. Now if you consider this 2 hydrogen and this boron, they are on the same plane. These 2 hydrogen and boron on the same plane, but these 2 hydrogen, they are up and this hydrogen down of that plane. Okay, so like this, means basically consider in this way. So same plane, and these 2 in different plane. Now read the options. 4 terminal hydrogens and 2 boron atoms lie in the same plane. Yes, 4 hydrogen and 2 boron, they are lying in the same plane. This is correct statement. They are asking not correct. Both the boron atoms are sp2 hybridized. Here we have this trick. Boron, normally if we consider BH3, yes, it is sp2. But if you consider B2H6, there each boron is having 4 bonds. And already we know, if we have 4 bonds, 4 sigma means sp3, 3 sigma means sp2, 2 sigma means sp. So this thing already we know. So each boron is having 4 bonds. Although this bond is not traditional bond, but still we have to consider it is a bond. So total each boron is having 4 bonds, that's mean sp3. B is wrong. 2 3 center 2 electron bond, yes, we have this. 4 terminal BH bonds and 2 center 2 electron bonds. Yes, these 4 terminal bonds and this is 2 center 2 electron. All these 4 bonds, 1 2 3 4, they are 2 center 2 electron bond. So answer is B in this case. They have asked not correct. Correct? Answer is B. So this is also very important molecule. You must revise this molecule. Achha, next this one. Which of the following is not correct? Again they are asking not correct about carbon monoxide. First statement, it is produced due to incomplete combustion. Correct, because carbon, if it reacts with oxygen, if it is partial combustion, then it will form CO, and after that it will form CO2 if you consider complete combustion reaction. So first statement, for incomplete combustion, there you will get this CO, carbon monoxide. It forms carboxyhemoglobin. Yes, hemoglobin means iron will be there, and CO molecule can form bond with iron, and that is called carboxyhemoglobin. Carboxyhemoglobin, yes, it is correct statement. It reduces oxygen carrying ability of blood. Yes, if instead of O2, if CO molecule is there, if CO molecule is forming bond with iron, then oxygen carrying capacity will be lost. Why? Just try to understand this thing. If you consider CO molecule, this carbon is giving its sigma electron, then this iron will back donate its electron to the empty pi star orbital of carbon monoxide. So back donation is happening. That's why this iron carbon bond, these are very strong bond. This is very strong bond as compared to iron oxygen bond. So you just tell me, if iron is attached to CO strongly, if iron is strongly attached to CO, then CO molecule cannot be released easily, right? Correct? So that's why oxygen carrying capacity will be reducing if CO molecule is involved in bond formation with iron or hemoglobin. So this is also correct statement. Last one, carboxyhemoglobin is less stable than oxygen. No. As I mentioned, hemoglobin means iron is there. Carbon monoxide can form stronger bond with iron as compared to oxygen with iron. So this is highly stable. That's why this CO molecule will not be released easily. Correct? And that's so this is wrong statement. Carboxyhemoglobin is more stable than oxyhemoglobin. That's why, you know, if you keep breathing in carbon monoxide atmosphere, then it will die. Definitely it will die. And what is the solution for this problem? For example, if you are experiencing lot of carbon monoxide exposure, in that case you have to inhale almost 100% oxygen. Why? Because if you inhale, if you increase concentration of oxygen, then that will pressurize to break this carbon and iron bond. Only in that case you can survive. Otherwise, normally it is not possible to to stay alive, because this carbon and this hemoglobin, this bond is very, very strong, almost 200 to 300 times stronger in terms of stability, right? So option D is the not correct statement. Next, 19th one, how we will solve this question? So correct coefficient they are asking, reactants in the balanced equation. So first, this is redox reaction, and already we know for redox reaction you have to balance individually. For example, this iron, what is the oxidation state here? +7, and here it is +2. So this is undergoing reduction reaction, and this CO2 to C2O4 oxalate, C2O4 2 - 2 CO2, this is oxidation reaction. So separately we have to balance them, then we will combine. So let's consider MnO4 minus, from that we are getting Mn2 plus. How we will balance? So here 4 oxygen we have, so write 4H2O, because medium is acid. So that's why we can easily write 8H plus here. correct? So first you have to do atom balance, then you have to do charge balance. So here how many net charge? Total 7 positive. There we have 2 positive. So that's why here you have to write 5 electron. So total net 2 positive charge, there also 2 positive charge. Next equation, C2O4, 2 minus, from that we are getting CO2. How to balance atom? Just put 2 here. Now how we will do charge balance? Plus 2 electrons. So now charge and atom both are balanced. So these two are separate reaction. This is 1 and this is 2. Now how to combine? Before that we have to equalize number of electrons. So there 5 and here 2. How we will do that? Multiply this entire equation with 2 and this entire equation with 5. Then first case total number of electrons 5 into 2 10, and in this case 5 into 2 10. Now if you add these two equations, what you will get? 2 MnO4 minus plus 2 into 8 means 16 H plus, and this electron and this electron will cancel out, right? If we add, there are 10, here also 10. At the left side here we have 5 C2O4 2 minus. Now come to the right side, 2 Mn2 plus 4 into 2 8 H2O plus 2 into 5 10 CO2. Done. This is the balanced equation. Now just check what they are asking. So first reactor means this sequence you have to follow. MnO4 minus 2. Next C2O4 2 minus, here 5. Next H plus 16. So 2 5 16. Option B is the correct answer. So this sequence you have to follow, right? So this type of redox reaction or balancing redox reaction, you can expect question. This is acidic medium, then basic medium we have, that thing also you should revise, right? Okay, this is option B. Next, this question. Can you answer this question? Disproportionation. So how we will define this disproportionation? So means one oxidation state, one to many oxidation state you will get, and in that many it must be oxidized. In one case it will be oxidized and reduced. So from one oxidation state you will get many oxidation state, and just verify in those many oxidation state whether the same element is undergoing oxidation and reduction at the same time or not. If it is yes, then yes, it is a disproportionation reaction. And if you do opposite, this is dis, and if you do opposite, then it will be comproportionation, means many oxidation state to one oxidation state. Now just check here. First example, copper. Here +1 and here charge and oxidation number same for element, right? So here +1, here +2 and here 0. Yes, from +1 to 0 it is reduction R, and +1 to +2 this is oxidation O, correct? So that's why, and from one oxidation state we are getting many, means more than one, so it is disproportionation reaction. Next, in this case manganese, what is the oxidation state? +6, and here it is +7 and here it is +4, correct? So from +6 to +7 it is oxidation, and +6 to +4 it is reduction. Yes, one to many, again it is a disproportionation reaction. Now last one, third one, here it is +7. Now just check, here it is +6, correct? And here it is +4, +4. Here it is +4. Now you tell me, from one oxidation state we are getting many, that is okay, but both are reduced, right? Both are only reduced, there is no oxidized one. Like here +6 to +7, one more, and 4 less. So oxidation and reduction both are happening, but here only reductions are happening. So that's why it is not disproportionation reaction. So in this case you see plus 7, this is plus 7, it is plus 2, and here it is plus 4. So from plus 7 and plus 2, from many you are getting 1. So it is com-proportionation reaction. It is com-proportionation reaction. So that's why if you analyze this thing, only 1 and 2 are disproportionation reaction. Again, I am expecting that from com-proportionation and disproportionation they can frame question, because this is very important topic. Okay, chalo, next question. Answer is A here. So this one, based on IUPAC name, yes, they can frame question. IUPAC name is very important. So which one is not correct? Just check. So here how to put parent chain numbering, 1 2 3 4 1 2 3. So 1 2 3 4 5 6 7, this would be the numbering, right? Longest chain, nearest substituent, right? So now this is methyl, starts with M, and this is ethyl substituent, starts with E. Now you know, to name substituents we follow alphabetical order, right? First ethyl should come, then methyl, but here first ethyl they have written, so that's why already we have got the answer. This is wrong. Next, let's verify other options also. So here 1 2, always remember functional group is having higher priority. So this is 1 2 3 4. So at 3 we have methyl. So 3 methyl, 2 butanol or butane 2 all. 2 butanol or butane 2 all. Both are same. So it is correct. This one 1 2 1 2 3. So 1 2 3 4 5. This would be the parent chain because triple bond is having higher priority. So 4 methyl pent 2-ine, 4 methyl pent 2-ine or 2 pentyne. This is also correct. Check this one, how to put name, means parent chain number. Double bond is there, so that's why higher priority 1, and this is 2. Now 3 4 3 4, but there we have substituent, so that's why 3 4 we will put there. Nearest substituent. So here we have, this is one and this is another one. 2 substituents we have, and ethyl should come first. 2 ethyl, then 3 methyl, total 4 carbon in the parent chain but, and 1 carbon we have in, so 1 butane. So all 3 B, C, D are correct, only A is wrong. So correct answer here will be A. Next, this one, strongest base. How we will find out? So here you have to know that availability of lone pair, availability of lone pair. If lone pair is available, then it will be stronger base, means it will easily donate to H+. That's why stronger base. Now just check here, this nitrogen is having lone pair, but this nitrogen is sp2, and this lone pair, this is pyrrole, and this lone pair is participating in resonance. So this lone pair is not available at all. This lone pair, yes, it is sp3, this is available, and this nitrogen, it is also participating in resonance. Now you just tell me in which case lone pair can be easily donated to H+. Obviously this pi-pyridine system, C. The reason is that, so here we can easily eliminate because of aromaticity, this pyrrole, it will not show that much basicity because lone pair is not available. This nitrogen lone pair, it will be in conjugation, right? So that availability is not that much. And this lone pair, it is available. It is not in any type of conjugation. It is not in conjugation, but this nitrogen is sp2. Higher S character means this nitrogen will not try to lose this lone pair, right? So only if you consider option C, here nitrogen is in sp3 so it can easily donate this lone pair of electrons. So if you see the basicity order, C will be the strongest base, then A, then D, and at the end B. This would be the order. So highest or strongest base will be C. Correct? Next, this question, number of sigma and pi. How to find out? So this is connected to IPSC name, right? Paint. So first you have to draw the structure. 1, 2, 3, 4, 5. 2 in. So this is second carbon, 2 in, 3, 4. 4 carbon we have ein. This is the structure. Now put hydrogen. Put all the hydrogen. Now calculate number of sigma and pi bond. How many sigma? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sigma. Already we got the answer. 10 sigma. And pi, this is 1 pi. This is 1 pi, 2 pi, 3 pi. Total 3 pi. So answer A. So sometimes they will give the name, IPSC name. You have to find out their sigma bond, pi bond, like that. Okay. Answer is A. Next, this question. Try to solve this question. sp2 hybridized carbon atoms and pi bonds they are asking. Just if you draw this structure, C triple bond C, bond C, double bond O, bond O, CH3. Okay, and now sp2 means, always remember, 3 sigma bond. 3 sigma bond means sp2. Now if we consider for benzene, all these 6 carbon means all are sp2. sp2, 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 sp2. All are sp2. Acha, this is sp, this is also sp, and this, how many sigma? 1, 2, 3. So that's why sp2. And this one, lone pairs we have. Always you have to see, you have to consider lone pair also, not only this sigma bond plus lone pair. So it is actually sp3. Oxygen is sp3. Carbon is also sp3. Okay. So how many sp2 hybridized carbon we have? 1, 2, here 6, and there 1, 7. Total 7. So 7 and 7. So other two options by default they are wrong. Now calculate pi bonds. So here see, here we have 3, here 2, 5, and here 1, 6. So option C will be the correct answer. Okay, option C, 7, 6, that is the correct answer. Next, this one, Kjeldahl's method. This is very, very important method for the estimation of nitrogen. So in which case it will be used? See, Kjeldahl's method, it is used to estimate nitrogen. Everywhere you see, all these options they are having nitrogen, but we cannot estimate hydrogen for all of this case. Only in one case we can estimate. Remember, in Kjeldahl's method, finally we will get ammonia. So ammonium sulfate we will get, from that finally we will get ammonia. So can you convert this molecule, this nitrogen into ammonia, this nitrogen into ammonia, this in ammonia? Nitrobenzene, it is not possible. Pyridine, not possible. Then azobenzene, not possible. Only in case of this you can get ammonia from aniline. This is the limitation. This question is framed from the limitation of Kjeldahl's method. Remember, we have nitrobenzene, pyridine, then azobenzene, right? They will not respond to this test. Only aniline is exception. Aniline can give this test, right? This is very, very important question based on those quantitative analysis. And we have one, note. So here answer is C. So this is our note. This is very important. If I talk about your exam, Liebig's method. So there carbon and hydrogen we estimate. For carbon, CO2 is framed, CO2 is formed, and for hydrogen, H2O. Dumas method, N2 molecule is formed. Dumas and Kjeldahl's, both the cases, we use this method to estimate nitrogen. But for Dumas, N2 molecule, and for Kjeldahl's, ammonia is produced. And already I hope you know the formula of this estimation techniques. For sulfur, end product is BaSO4. For phosphorus, Mg2P2O7, and for Carriers method, AgX. Sometimes they can ask end product of this Kjeldahl's or other methods. For example, in Carriers method, what will be the end product? AgX means silver chloride, bromide, iodide. Fluoride we cannot estimate. Phosphorus, end product is Mg2P2O7. Then sulfur, barium sulfate, BaSO4. So like that. Kjeldahl's ammonia, Dumas N2. Then Liebig's method for carbon CO2, for hydrogen H2. So end product they can ask, or they can ask that direct calculation, percentage of carbon or hydrogen, nitrogen, sulfur, phosphorus, or halide. They can frame question based on this also. Just revise these formulas, right? Achha, next, this question. Can you answer this question? So basically here we have total 3 different types of R, correct? And we are using KMnO4. So in which case we can convert this hydrogen into H? In which case this oxidation reaction will be happening? And we have a lot of combinations with hydrogen and methyl. This question seems it is very difficult, but just if you know that small concept, you can easily answer. This oxidation of KMnO4, oxidation by KMnO4, it follows radical method. Radical method. And whenever we consider radical method, 3 degree radical is more stable than 2 degree and then 1 degree. 3 degree or tertiary radical is more stable than secondary and then primary. Now just check, if you put all R group, if you replace all R with methyl CH3, then it will become tertiary and this radical will become very stable, right? And if you replace this R with hydrogen, that means stability will be decreasing in that case. So just check in which case we have all R group with methyl. So option B will be the correct answer, because in this case only tertiary radical will be produced, which is very much stable. Okay. And also if you consider CH3 group in all these cases, because of the inductive effect, this carbon hydrogen bond, it will be very weak bond in this case. This carbon hydrogen bond is very weak. Already it is weak, and once you remove this hydrogen in terms of radical, then that tertiary carbon radical, that is gains much more stability because of that hyperconjugation or inductive effect. Okay, so answer will be B here. Next, this question. The major product C in the reaction, in the below mentioned reaction. So how we will gauge the product? Always remember, whenever we have alcoholic KOH, then elimination reaction will be preferred. Elimination reaction will be preferred. Whenever we have aqueous KH, then substitution reaction will be preferred. Substitution. So in case of alcoholic KOH, elimination product. In case of aqueous KOH, substitution product, right? Now what will be that is the normal basic idea. Now just see the option. Now let's carry out this reaction. CH2Br. So first step, aqueous KOH elimination. So it will HBr will be eliminated. So CH3 bond CH, double bond CH2. Next, HBr. HBr we are adding. So HBr adding means Markovnikov rule, rich gets richer, means carbon having more number of hydrogen will get hydrogen again. So this hydrogen will be attached, this hydrogen will be going towards this carbon. This is Markovnikov rule. So we will get CH3 bond CH, Br bond CH3. Next, aqueous KOH. If you give aqueous KOH, then this bromine will be replaced by that OH, means substitution. So you will get CH3 bond CH bond OH and there CH3. So basically 1, 2, 3, prop to all or propane to all. Okay. Option B is the correct answer. So always remember, this is again based on the basic concept. Alcoholic KOH means elimination, aqueous KOH means substitution. Okay. Next question, this one. The most suitable reagent for the following conversion. See, sodium liquid ammonia, already we know this is Birch reduction, Birch, and which gives trans product. Birch reduction is always for trans product. Lithium or sodium, both can be there in liquid ammonia. So that gives trans product. Then hydrogen in palladium carbon quinoline, this is Lindlar catalyst, right? Lindlar catalyst. So in that case, always we get cis product. Zinc HCl. So basically it is used to get ketone type product, means alkyne, means ketone to it is actually used if we have C double bond O, from that we will get CH2 like this. For ketone type of product if you have, so to reduce that we use zinc related, zinc HCl, zinc amalgam HCl, that thing. Now this mercury H plus H2, so that is used if we have triple bond or something, alkyne product, from that we can get ketone using this method. So these two are totally different, it is not connected to this, only A and B you have to decide. Since two CH3 group, they are on the same side, so this is cis product, right? So that's mean option B is the correct answer. So Lindlar catalyst here you have to use. That is the most suitable reagent. Okay. Next, this is the last question, 29th question. So you have to find out which one will be the correct product. And here what we are adding, Br2 in presence of FeBr3. So basically it will give Br plus electrophilic substitution reaction, right? It is an electrophile. Now just check, electrophile means it wants electron. It wants electron. Now this is our reactant, in which case we will get maximum electron density. So here we will get maximum electron density. After that these two places, correct? Ortho position. First at this position we have maximum electron density. After that these two position. But if we consider this position here, strong steric hindrance also will be there. Steric hindrance will be there. So that's why, although this position is having highest electron density in this case, but still there will be no substitution. Br plus cannot attack that position. So what is the remaining possibilities? Only this and this. Check the option. Only in case of D we are getting this two possibilities. And why in this case there is no bromination? Because this is meta position and by default here we have least electron density. Least electron density. In this case, least electron density. And we know if the electron density is less, Br plus will not attack there, because Br plus is electrophile, right? It wants electron. Why it will go to a position where electron density is not there, correct? So that's why option D is the correct answer in this case. Okay. Yes, see, we have discussed all these 29 questions. Each of them is really important for your NEET RE-NEET 2026. Revise all those questions, and this is our Telegram channel. Join this channel to get updates, and this is our YouTube. Already you are watching, so subscribe. Again, we are going to discuss another set of questions, which will be covered mostly, which will be covering class 12th chemistry. So these are all about class 11th chemistry, and that will be covering 12th chemistry. So you will get all the notification if you press bell icon. So just do subscribe and do like all these videos. Okay, thank you very much.